Hello and welcome back, Algebra 2 people. I have missed you. So today, as you can see, we're starting with the Solving Quadratics unit. But before we can actually do any solving of quadratics, we're first going to learn about, well, what the heck are they? So right here, I've got this chart, and I'm going to show you this chart on almost every single slide that we're going to do today. This chart's going to help you simplify radicals. All it is just a list of numbers from 1 through 20 and showing you what those numbers would be squared. Now, if I wanted to go backwards, like let's say I want to start at the number 36, I could take the square root of that, and the square root is 6. So you could also use this as a square root chart. Alright, so let's go on to our first problem. So the first one is the square root of 75. So you could go ahead, try typing that on your calculator. I'll get mine out, and I don't have any arms that you can actually use, so I'm just doing this with my mind. 75 square root, it is 8.6602540388 something. So I can't use that. I need an exact value. So to get an exact value, I'm going to look here at this beautiful chart of mine, and I've got to try to find a number that will go into 75 evenly. So let's look up here, and the first number I'm going to start with is the first one that is equal to or less than 75. So all these numbers are bigger than 75, and then right here is where 75 would be, in between the 81 and the 64. So I'm going to start trying to divide by 64. 75 divided by 64 does not give me an integer. I divide by 49. 75 divided by 49? No. Divide by 36? No. 75 divided by 25, though, that works. 75 divided by 25 is 3. So what I'm going to do is I'm going to rewrite this. So instead of just the square root of 75, that's the same as 25 times 3. So all I did was I took the 75, divided it by all these numbers until I got one that worked. Once I got that, I'm going to do 75 divided by 25 equals 3. You would agree that 25 times 3 equals 75. If you're not sure, go ahead, use that calculator. Next, I'm going to think of these as two separate roots. So if I wanted to, I could also write it like this, where I have the square root of 25 times the square root of 3. Those are both the same thing. So what's the square root of 25? Well, that's easy. It's up here on the chart. If you don't know it, that's 5. So instead of the square root of 25, I'm just putting 5. What's the square root of 3? We don't know. So I'm just putting square root 3. And that's it. That's all we had to do to reduce. Now, if you're not sure if you got the answer right, that's okay. We could very easily do this. You remember when we did the square root of 75 on the calculator, we said that that was about 8.660. Now I can do 5 square root 3 on the calculator. So the square root button, if you haven't used that before, is you hit the second or shift key and then x squared. So I'm going to type 5 and then my second key or shift, depending on what calculator you have, and then x squared. You'll notice above the x squared there's a little square root sign, and then hit 3 and then hit equals, and you should get the exact same answer. It should be 8.660 something something. Alright, so that's how we know we got this correct. Now, some calculators will do this for you entirely, but don't expect to use that on a test or quiz, so make sure that you actually know how to do this, not that you're just using the calculator that does it for you. Okay, next let's go on to the square root of 72. So 72, where does that fall on the list? It falls also right here between 81 and 64. So I have to find the first number that I can divide evenly into 72. So 72 divided by 64 does not work. 72 divided by 49? Nope. 72 divided by 36? Yes, that gives me 2. So this is the same thing as 36 times 2. What is the square root of 36? 6. What's the square root of 2? We don't know. So we put square root of 2. Again, if I wanted to check my answer, I would take out that calculator, hit square root of 72, and that gave me 8.485. Then on my calculator, I do 6, and then the second x squared, 2, and that also gave me 8.485. So I know that I'm correct. Let's move on to some more. At this point, we've already done a couple, so you may want to hit pause, try these, and then come back with us and see if we match. Okay, 18. 18 goes right here on my list. I have to try dividing by each of these numbers until one works. By the way, it's important for me to tell you, you want to start here at wherever I made that line and then work your way down. Don't start here at the bottom and work your way up, because, for example, something could be divisible by both 16 and 4, but 16 would be the thing that you would want to divide it by. You're just going to have to trust me. Start with that line and work your way down, not the other way around. All right, so 18. I tried divided by 16. For this one, that does not work. I tried divided by 9, though, and 9 does work. In fact, 18 is 9 times 2. The square root of 9, 3. The square root of 2 is the square root of 2. Okay, let's try it for 98. For 98, that's just less than 100, so I'm going to start way up there. 98 divided by 81, that doesn't work. Divided by 64, that doesn't work, but 49 does. So this is 49 by 2. The square root of 49 is 7. It says so right there, or you could do it in the calculator, and the square root of 2 just gets copied. And that's all there is to that. We'll do a couple more just for fun. Let's go for 162. 162 is right there. I'm going to try dividing by each of these numbers until I get something that works. 144, no. 121, no. 100, no. 81, yes, this does work in my calculator. 162 is 81 times 2. Once you have that, square root of 81 is 9. Square root of 2, I just copy. And that's it. Now, on we move to 26. Let me erase my board and start over here. 26 is just above the 25. I tried dividing by 25. That does not work. By 16, no. 9, no. 4, no. 1, only 1 works, but that doesn't really help me. So that means it's entirely simplified already. If you cannot divide our number by any of these numbers here, then it's already simplified. Now let's add in some variables. Before we do that, let's go and do a little practice. So if I had x to the 6th power, for example, you would agree that that's the same as 6 different x's all multiplied together. There they are, all multiplied, 6 of them. So what square rooting does is it's taking pairs of numbers. So for example, when we were doing the square root of 25, it was wondering what pair of numbers could I get? Well, 5 and 5 was a pair that matched, and when I square root that, that just gave me 5. So the same thing here. I'm looking for pairs of x's. There's one x, there's another x, there's another x. So here are your pairs. Now before, we were square rooting. Now once we've broken them out of the roots by taking them into pairs, I have x times x times x, which is x cubed. Now if this were x to the 100th power, I wouldn't want to have to write out 100 different x's. So the easy way is just to take your exponent and divide by whatever the root was. Since this is the square root, we're going to divide by 2. So your formula here is exponent divided by root is going to give you your new exponent after you've taken the root. You know that since this is a square root, it's like there's a 2 there. But we don't write the 2 because we just assume it's there if there's nothing there. Alright, so now that we know that, we should be able to do this. Now just like when we were doing GCF, I always do my numbers first, then the variables last. It makes it easier for your brain. So let's start with the 24. 24 would go here. I tried dividing by 16, no. 9, that doesn't work. I divided by 4 though, and that worked. That gave me a 6. So this is a 4 and a 6. I'm going to keep them in separate roots just to make life a little bit more simple. Now I have x to the 8th power. I'm going to worry about that after I've taken the square root though. So first, let's do square root of 4 is 2, and the square root of 6 is just the square root of 6. You'll notice that I've left room here and here because we might have some answers going in each, or maybe only in one. I don't know yet. Now for our number, or for our variable, I have x to the 8th power. Remember we said we're going to take this number and we're going to divide it by 2 because this is a square root. So 8 divided by 2 gives me 4, and exactly 4. There's no remainder at all or anything like that. So that's going to go here on the outside. 8 divided by 4, or 8 divided by 2 was 4, so the x to the 4th goes on the outside. And then I'm done. Since there was no remainder, there's nothing that stays inside the root. Okay, let's go on to this one. We've got the square root of 36. Let me clear my board. All right, now I have 36. Oh my goodness. You will notice that 36 is right there on the board. So we already know that it has an exact perfect square root. It's 6. So I'm going to just put 6. There's no root to worry about because I've already taken the square root. It's done. There were no leftovers. I didn't have to divide by anything. It was already divisible by 36. Now I have x to the 17th. So, like before, I'm going to take my exponent. Since it's a square root, I'm going to divide by 2. Now this time, when I divide by 2, that's going to give me 8.5, or 8 1/2. Here's what this means for you. The 8 is the exponent that goes outside. So this is the one outside of the square root, 8. Now, the fact that we have a 1 left over, that tells us how many x's are left over inside the square root. This is a 2 on the bottom because it's a square root. So really, the bottom number is not going to matter too much to you. You just need to remember to take your top number, the numerator, and put it on top here. Well, what if you did it only in decimal form? If you're doing square roots, 0.5 will be the only decimal you will get here. If it's 0.5, you just know that that's a half. And so there will be a 1 right here. So if you're doing square roots, the biggest number you can have here is 1. Because if you had a 2 here, that would be a pair, and they would leave the square root together. So 1 is the biggest exponent we can have for square roots. All right, let's move on to the next ones. 98. I feel like we've already done the square root of 98. Ooh, look, we have. It's 7 square root of 2. So I'm just going to use that information to help me with this one. 98 is 7 square root 2. So the numbers are done. Now let's worry about our variables. So with our variables here, we've got x to the 5th power. Like always, when we have a square root, I'm going to take this number and divide it by 2. That gave me 2.5, or 2 1/2. So that means I have 2 x's outside, and I have 1 x inside. Because of that 1/2, one of them will go inside the root. Now let's worry about our y's. This is y to the 16th. I take 16 divided by 2, and that gives me 8. Exactly 8. There are no remainders, so that means there's no y left under the root. And that's all we have. All right, I'm hoping that maybe you could hit pause now and try this one, and then we'll get back together and do it right now. Okay, so 28, let's start with that. 28 would go here. I tried dividing by 25, 16, and 9. None of those work, but 4 works. So 28, you would agree, is 4 times 7. So let's go ahead and root it. 4 is 2 when you square root it. I'm going to leave some space for x's and y's. And then the 7 goes down. Let's do our x's now. I have 9 x's. I'm going to take 9, divide it by 2. And that gives me 4.5, or 4 1/2. So 4 x's will go on the outside, and 1x will go on the inside. Now let's worry about the y's. So for y, I have y to the 3rd power, so I'm going to divide this by 2. That gives me 1.5, or 1 1/2. So there will be 1y going on the outside, and there's 1y on the inside. And there it is. Okay, now let's move on to dividing. Well, when you divide, if you have one big root over a whole fraction, then that is exactly the same as if I take that square root and put it over only the top and only the bottom. Uh-oh, my pen's running out of ink. Sorry about that. There we are. Okay, so now I try to see, can I take the square root of 17? Well, I tried dividing 17 by 16, 9, and 4, and none of those work. So 17 is not square rootable. It's just the square root of 17. You can't reduce it. Square root of 25, though, ooh, look here. We know the square root of 25. It's right there. It's 5. So I'm going to change that to a 5. And that's all we had to do with that one. Now we have this one, the square root of 16 over the square root of x to the 8th. Just like all the times before, we're going to square root the 16, and great news for us, 16 is right there. We know his square root is just 4. So when I rewrite it, I'm just writing a 4. No root over the top because I've already busted him out of the jail of the square root. Next, x to the 8th power. Remember, if it's an exponent, we divide by 2. So 8 divided by 2 gives me 4. So that's an x to the 4th. Notice again, it's outside the root because I already divided by 2. Now let's talk about cube roots. With cube roots, instead of a number times itself just once equaling something, now we're going to have to do a cube chart. And I don't have a pretty one for you, but that's okay. Let's do one. So if I 1 cubed is 1 times 1 times 1, which is 1. 2 cubed is 2 by 2 by 2, which is 8. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. 6 cubed is 216. 7 cubed is, I don't remember, 343. And then once you get up to these bigger numbers, honestly, I don't even remember them. But 8 cubed is 512. 9 cubed is, 729. And 10 cubed is 1,000. Probably you're not going to get up this high, but I put those there just for fun. Alright, let's start with 81. Now, there is a negative here, which normally would freak you out. With square roots, it's not possible for that to happen. At least not as far as you know, because you're only in first year algebra. But for these, when we have an odd root, we're allowed to have a negative sign there, because a negative times a negative times a negative is a negative. Okay, so I have to think of what times what times what is 81. Well, nothing. So I'm going to start here, and I'm going to divide all of these numbers into 81 until I find something that works. So I tried 64, that did not work. I tried 27, oh yes, that did work. So I have cube root of 27 and the cube root of 3, because 81 divided by 27 is 3. Now this was a negative 81, so I'm going to put a negative here with my 27. So on your calculator or in your brain, probably in your brain because it's even easier, 27's cube root is 3. So instead of this, I'm going to put 3, and because there was a negative sign here, I'm going to put a negative 3. Then for this, just like we did before, we're just going to copy it because we don't know what it is reduced. It is already reduced for us. And that's all. So it's the same thing, we're just using a different chart. Let's do another one, 128. Well, 128 actually starts right here. I try dividing by 125. That does not work. 64 though, that works. So I've got the cube root of, again, this was negative, so I'll put a negative there, 64. 128 divided by 64 gave me 2. Okay, next I'm looking at 64. That went with 4. So right here I'm going to put a 4, but since this was negative, so is this, and then copy the right side. And that's all for that one. Next, in addition to cube roots, let's go ahead and put in some exponents for variables. So this again is the same as the cube root of x to the 12th over the cube root of negative 64. Alright, so let's do each one separately. Let's start with the 64. We're going to go back and use our cool chart here. 64, ooh, that's perfect. It's 4. So looking at this, since this was negative, I'm going to put a negative 4. And that's it. I busted it out of the root because it was perfect. It was right on the chart. Now, before, I would take this exponent and divide by 2 if it were a square root. However, since this is a cube root, I'm going to take 12 divided by 3. That gave me 4. And that's all there is to that. Let's do another. I'm going to think of this as 2 separate cube roots. I misspelled 125, sorry. The cube root of 125. Let's go back to the cool chart I drew. And 125, oh my gosh, it's a miracle. Look at that. 125 goes with 5. So I'm going to go over here, and instead of 125 cube rooted, it's just 5. He's been broken out of the jail of that cube root. Now I've got x to the 8th power all cube rooted right here. So I'm going to do 8 divided by 3. Well, that's going to give me something kind of ugly. 8 divided by 3 gives me 1 2/3, or 1.6 repeating. You'd rather it be in this form because this big number tells you how many x's busted out of the cube root. So there's 1 x outside the cube root. Inside the cube root, however, you have 2 remaining because that was a 2/3. So I'm going to put 2 there on the inside. And that's all there is to that one. Okay, so that's all we were going to learn with simplifying those. Now I just want to do one simple, easy, real-life problem for you. So I used to live near Chicago, and I used to really enjoy going up to, actually a friend of mine worked right here on the top of the Hancock Center, but we're going to be in Willis Tower for this problem. So inside Willis Tower, at the very, very, very top of the observatory, your head is going to be 1,450 feet above the ground below you. That's really tall. Alright, so you're going to go up there, and we want to find out how far across can we see. For those of you thinking this is the ocean, this is really Lake Michigan, by the way. So we want to see how far across on the ground can we see, and we're just going to use this formula here. This is a cool little formula that tells you how far you can see if the ground is flat and if you're high up in the air. So D is going to be the distance we see, H is going to be the height of our eyes in feet. So the square root of 3h over 2, let's write this here. And actually I'm going to write it like 2 separate square roots, just like that. Okay, now this says our height is 1450, so that's going to be our h. So I'm just going to rewrite this equation. So it is square root of 3 times 1450 all over the square root of 2. So go ahead and do 3 times 1450 on your calculator. And then mine says that that is 4350. And then I have the square root of 2 on the bottom. Great news. Remember, if these are 2 separate roots, that's the same as if they were all under 1 radical. So I just wanted to show that to you, just to remind you of that rule. So go ahead, do 4350 and divide that by 2. That gives us 2175. Notice this is still under the root because I've not done any rooting or anything with the chart. Alright, now before, when I wanted an exact value, I would use this cool chart here in order to reduce it. However, for this one's a word problem, so I'm going to go ahead and have us calculate it on the calculator. So do 2175 square rooted, that's the second or shift button and the x squared, and you should have a value of about 46.637 miles. So the distance you can see in miles from the top of the Sears Tower is 46 miles. That's really far, but as you can tell, you can see really far. Alright, next, let's go to solving using square roots. This is normally everybody's favorite part of the chapter because they are so easy to do. If you remember how to solve a one-step equation, two-step equation, then this should be pretty simple. My hint for doing this is just to pretend you're solving for x. Pretend the x squared, the squared part, is not there. So what would you do to both sides if that were just an x? You would add 4. So now I have x squared equals 4. Once you get that square root all by itself, or once you get that x squared all by itself, then you need to cancel the square. The way to cancel a square is a square root. It's like the kryptonite to the squared. Do a square root. Then we have x equals, a lot of people are shouting 2. But you'd be wrong. It's not just x equals 2. Something crazy happens when we do this. If we have a square root over an x squared, we have to put a special symbol here. It's called the plus or minus symbol. Plus or minus. Because this actually could be a positive 2 or a negative 2, and it will still work. Why is that? I'm glad you asked. Alright, so let's go back to our original equation. X squared minus 4 equals 0. I'm going to write it twice because I have two answers, just to prove to you that this works. So I could put a 2, there's our 2, I could put a 2 instead of x. 2 squared is 4. And yes, 4 minus 4 is 0. Yay! But I could also put negative 2 right here. Negative 2 squared, which is negative 2 times negative 2, is also a positive 4. So 4 minus 4 still gives us 0. Both answers are correct. So we need to include both the positive and the negative 2 in our final answer. This is a really important thing that people forget a lot. You'll be using this the whole unit, so please, please, please get in the habit of using the plus or minus. Alright, this one's a little bit trickier, but not too bad. You would know to do this minus 6 from both sides. Then we would divide by negative 5, and we get x squared equals 100. Then finally the x squared is all by itself, so I'm allowed to square root now, and that gives us x equals 10, right? No, of course not. You all knew to put the plus or minus there. Great job. Okay, let's do another. Remember, if there's no number touching an x or an x squared, we always like to put a 1 there so that we don't make a silly mistake. Do you have the answer for this? Alright, some of you think so. Let's go ahead and subtract 3 from both sides. So that gives us negative 1x squared equals 25. What would you do to both sides? If you said square root, you're wrong. Sorry, I cannot square root yet. I first have to divide by negative 1 because the x squared is not by itself yet. Now I have x squared equals negative 25. So, what does x equal? If you said 5, you're wrong again. I'm so sorry. So, we're going to square root both sides. Uh-oh. If you type this into your calculator, it will explode, so don't do that. We've got the square root of negative 25. So that is no real solution because we don't know how to take the square root of a negative number yet. 2 years from now, when you're in second year algebra, then you can do it, and there's something special about that. But for now, we're just going to put no real solution. All right, this one is in factored form. Don't let that scare you. It is so easy. Now remember when I said if you had the squared all by itself, then you can go ahead and square root. Well, this is one of those cases. The squared is all by itself on the left side. That whole left side is squared. So I'm going to square root the left and the right. When I square root the left, remember the square root and the square will cancel. Those are gone. And then I just copy what's left. So I just had x plus 4. Then the square root of 25, we of course put 5. Huh? Hopefully you're telling me plus or minus 5, and then I would agree. Now those parentheses, when I knocked out that root and the squared, I really don't need the parentheses anymore. So if I want to, I can just get rid of them. Now I have x plus 4 equals positive or negative 5. What I've noticed is that if people will write out the two equations, they will do much better. So x plus 4 equals positive 5 and x plus 4 equals negative 5. Now let's go ahead and subtract 4 from both sides for both equations, here and here. I almost forgot my negative. And then this gives me negative 9 and positive 1. And that's it. That's all there is to it. Both of these answers, if I substitute them back here, both of them will work. Now we're going to solve by finding square roots just like before, except this time it will not have a perfect square. Let me show you what we mean. So just like before, I would subtract 4 from both sides. I get x squared. Now 24 minus 4, that's going to give me 20. Now I'm hoping you really understood that previous section that we just went over with the square roots, because that's going to come in handy right now. You would know that we're square rooting, both sides. So that's going to give me x equals, hopefully you're shouting plus or minus, but then I don't know the square root of 20. So let's go over here to my chart. I would start there, divide by 16, no, 9, no, 4, yes. So 20 is the same as 4 times 5. So let's try again. What's the square root of 4? 2. What's the square root of 5? We don't know. So if I asked you for an exact value, you would tell me it's plus or minus 2 square root of 5. If I asked you to approximate the value, this one's saying rounding to the nearest hundredth. So what I can do in the calculator is I can kind of check my answer actually. Right here, there, I have the square root of 20, and here I have 2 square root of 5. Both of them should give me the exact same decimal value. If they don't, then I screwed up reducing. So when I type that into the calculator, either the square root of 20 or 2 times the square root of 5, both of them will give me 4.47, rounded to the hundredth. All right, let's move on. Now, we already did one example, so I think, hopefully, you should be able to do this one. Go ahead and try this one, hit pause, try it, and hit play again when you're done, and let's see if we match. All right, hopefully you finished it. We're adding 7 to both sides, copying down negative 3x squared equals negative 36. Sorry, I was thinking it was going to equal something else. Then I divide by negative 3, and I got x squared equals 12. Everyone okay with that? Next, you square rooted both sides, and I got x equals square root of 12. Uh-oh, I know it's plus or minus. Now I have to split up my 12. Using my cool chart that's way over here, I tried dividing by 16. That didn't, oh, that's too big. I would have started here. I tried dividing by 9. That didn't work. I divided by 4. Yes, 4 works. So 12 is 4 times 3. So let's do, what's the square root of 4? 2. Square root of 3, we don't know. So my exact value would be plus or minus 2 square root of 3. If I had to approximate that, remember I can check my answer very, very simply by looking at both this square root and that one. So I would hit square root of 12 on my calculator, and that gives me 3.46. I could also type 2 square root 3 on the calculator. That should also give me 3.46. Now let's do a word problem. We have a square that has an area of 49 square feet. So let's pretend that I can draw, and that's a square. We don't know what this is. We don't know what this is. But they're both the exact same measurement because squares have equal sides. So to find the area, I would do this number times that number. So x times x is x squared. I know that the area is 49. So x squared equals 49. Well, this is a rather simple one. All you have to do is square root both sides. Now I have x equals 7. Now, some of you who were paying attention before would be saying, shouldn't that be plus or minus? Normally, yes. However, in this case, we can't have a side length of -7. Otherwise, our square here would be making a black hole, and that's not allowed. So x is 7 is just our final answer. Let's do another one. This time we have a radius of a circle. I'm not even going to try drawing a circle on this, so I'm going to cheat and just have it draw one for me. So the radius, we don't know what that is, so I'm going to put r. But I do know that the area is 100. How do you find the area of a circle? Hopefully you know it's pi r squared. Now, what's happening between that pi and the r squared? They're touching each other, so that means they're multiplying. In order to do this, I have to first get rid of the pi before I can square root. So divide by pi on both sides. The pi's cancel, and then I'm just going to copy exactly what I have, 100 over pi. Now I have this square root all by itself, so I'm going to go ahead, a square all by itself, so I'm going to go ahead and ruin the surprise for you and square root it. Now remember, like before, if I wanted to, and I definitely do, I can put a square root on the top and on the bottom just like that, and think of them as two separate roots. So now I have r equals, now again, normally I would have a plus or minus here. However, for this one, I need only a positive because it's a length. I can't have a negative length. The square root of 100 is 10. 10, there we go. And the square root of pi, well, I don't know what that is, so I'm going to leave it as the square root of pi. So if I asked you for an exact value, that would be great. But since we said round to the nearest tenth, I'm going to go ahead and type this into the calculator. So go ahead, hit 10 divided by square root of pi. That's going to give me 5.6 if we're rounding to the nearest tenth. And it was in inches. So 5.6 inches. Well, this is going to be a sad moment because we're totally out of time for today. Thank you so much for joining us. If you have any questions, you know where my email address is right at the bottom of my Canvas page. You know what my office hours are. Just in case you don't, they're also listed on the Canvas page, along with a link on how to visit me at my office hours. And you know that the homework assignments are also on the Canvas page. Everything in one spot, easy to find. Alright, if you have a question, go ahead, email or drop in on my office hours. Otherwise, just get started on that homework. Have a wonderful week, everybody.